So hello everyone. Today we are going to discuss is the properties of the smooth muscle. The first is the excitability. So what do you mean by excitability? Remember, excitability is the reaction or the response to tissue or irritation or the stimulation. So remember, excitability it's a physico chemical change, right? Now there can be various stimulus like the mechanical stimulus, electrical stimulus, thermal stimulus or the chemical stimulus. What could be the mechanical stimulus? Imagine you accidentally pinch your finger. So the pinching action, it is a mechanical stimulus that causes your skin and the nerves to react. So you feel pain and you might pull out your hand away. So that reaction is due to the excitability of the tissue responding to the mechanical irritation. Right? Apart from that, there could be electrical stimulus. Have you ever received a mild electric shock from touching a doorbell after walking on a carpet? So the electric shock is a electrical stimulus. So that would cause sudden reaction to your muscles, making you jerk your hand away. The third could be the thermal stimulus. Think about touching some very hot, like the heated glass rod or piece of ice. So the extreme temperature change is what we call it as a thermal stimulus. So if you feel too hot, you immediately feel the heat and pull your hand away. Last could be the chemical stimulus. Imagine accidentally spilling a few drops of strong acid on your skin. So the chemical substance, it will act as a chemical stimulus. Now, can anyone give me an example of the stimulus and how it might cause reaction in the body? Now, the stimulus, depending upon the intensity or the strength, we categorize the stimulus. It can be either subminimal stimulus, minimal stimulus, submaximal, maximal stimulus or supramaximal stimulus. Next important part is the strength duration relationship. So whatever the strength of the stimulus, it must be applied for a minimal duration in order to excite the tissue. So for a stimulus, remember, a minimal strength in order to excite the stimulus, in order to excite the tissue, a minimum stimulus or strength that is required. A minimal stimulus has a strength that is sufficient to excite the tissue. Let us talk about the strength duration curve. So the relation between the strength and duration of stimulus, it is demonstrated by excitation curve or we call it as a strength duration curve. In order to obtain the curve, we plot the strength of stimulus. So this one is showing the strength of the stimulus vertically and the duration that it would be in the millisecond horizontally. So we start with the high strength stimulus and measure the minimum duration required to excite the tissue. We then decrease the stimulus strength and measure the duration with each time and measure the duration each time. So plotting all the results to create a curve. Now what are the characteristic features of strength duration curve? The shape of curve is similar for all excitable tissue. So first of all, that the feature that would be you will see is the Rio base. So this one is the Rio base. What is Rio base? That means the minimum strength of stimulus that can. So Rio base is the minimum strength, that is measured in voltage, of stimulus that can excite the tissue. So remember, the voltage below this cannot excite the tissue no matter the duration, and it is also known as threshold strength. So point R on the curve, it shows the Rho-waves. The second important feature is utilization time. So utilization time, it is the minimum time that is required for Rho-basic strength of stimulus to excite the tissue. The third is the chronaxy. What is that? The minimum, so this is the chronaxy, that is the minimum time required for stimulus with double the Rho-basic strength to excite the tissue. So remember, the longer the chronaxy, the lesser will be the excitability. So it helps to measure the excitability of the tissue and compare the different tissues. Now remember this chronaxy, it will be used to measure and compare tissue excitability. So what is chronaxia? It is the minimum time that is required for double the Rho-basic strength to excite the tissue. So remember, if the chronaxy of the tissue is long, what does it indicate about the excitability? So there would be that indicate that the excitability would be lower. Now let us discuss about the variation in the chronaxia. Just that chronaxia, it is a measure of the tissue excitability, right? And it is 10 times more in the skeletal muscle of the infants. It is shorter in the pale muscles than in the red muscles. It is shorter in the warm blood animals than in the cold blooded animals. It is shorter during increased temperature and prolonged during the cold temperature. It is longer in the paralyzed muscle than the normal muscle. It is prolonged gradually during progressive neural disease. So why do you think that chronaxia is longer in the paralyzed muscle? Because it's because the paralyzed muscle, they have a reduced excitability. Other important term is that you need to know is contractility. So contractility is the response of the muscle to contraction. Now, what are the types of contraction? We classify the muscle contraction based into two types. The first is the isotonic contraction and other is the isometric contraction. In isotonic, remember the word is a T. So here the tension remains the same and length that changes. So when you flex your arm, remember the muscle fibers, they become shorter, while the tension, it remains the same. That is example of isotonic contraction. Other is the isometric contraction. In isometric contraction, remember the length of the muscle, it remains the same, while the tension, it increases. So when you try to lift a heavy object, your muscle, they become stiff and strained with increased tension. And but the length, it will not change. So that is example of isometric contraction. Now let us talk about the simple muscle contraction, that is also known as muscle twitch. So when a threshold stimulus is applied to muscle, it will contract and then it will relax. So that can be recorded graphically as a simple muscle curve. So we have 4 points on the curve. The first is the point of stimulus, the time when the stimulus it is applied, point of contraction, the time when the muscle begins to contract, the point of the maximum contraction, the point up to which the muscle contracts. It also indicates the beginning of relaxation. And fourth point is point of maximum relaxation. The point when the muscle relaxes completely. Now these 4 points divides the muscle curve into 3 periods. The one is the latent period, the second is the contraction period, and the third is the relaxation period. The latent period is the time between the application of the stimulus and start of the contraction. And contraction period is the time during which the muscle is contracting, and the relaxation period is the time during which the muscle it relaxes back. It relaxes back to its original position. Now what is the difference between isotonic and isometric contraction? In an isotonic contraction, the muscle length changes but the tension it remains same. Whereas in isometric contraction, the muscle length it will remains the same, but here the tension would increase. Now what are the factors that would affect the force of contraction? Like the strength of stimulus. When the muscle is stimulated by a stimuli with a different strength, the force of contraction it can also varies. So there could be subminimal stimulus. The stimulus it has a strength less than the minimal stimulus and does not produce any response. In response, so what happens if we apply a subminimal stimulus to a muscle? The muscle would not contract. So this stimulus is just sufficient. The second is the minimal stimulus. So the minimal stimulus is sufficient to excite the muscle and produce a muscular contraction with minimal force. So what is the minimal strength needed to cause a muscle contraction called? It is the minimal or threshold stimulus. Other is a submaximal stimulus. So this has a strength more than the minimal stimulus but less than the maximal stimulus to produce a contraction with more force than the minimal stimulus. Other is a maximal stimulus, and at last is the supramaximal. So this stimulus is beyond the maximal stimulus. So beyond this strength, the force of contraction cannot be increased. The second is the number of the stimuli. The contractibility of the muscle changes depending upon the number of stimulus applied. If a single stimulus is applied, the muscle contracts once, producing a simple muscle twitch. And if 2 or more stimulus is applied, then it could have various effects. It could have a beneficial effect. So what is beneficial effect? When you apply 2 quick stimulus to a muscle, so these are the 2 stimuli to a muscle, the second one comes right after the first has relaxed. So the muscle's second contraction is stronger than the first. So this stronger second contraction is called the beneficial effect. So why does this happen? So remember the first contraction, the muscle it heats up. So this heat would make the muscle less sticky. So due to that, the muscle it can contract more forcefully the second time. So the first stimulus, the muscle contracts and then relaxes, and in the second stimulus that comes right after, the muscle has relaxed. So the second contraction is stronger. So the first contraction warms up the muscle, reducing its stickiness, making it easier and more powerful for muscle to contract again. Other is the super position. So when you apply two stimulus to a muscle and second one comes during the relaxation period of the first twitch, you get two curves. The second curve, it overlaps or it is superimposed on the first curve. So this is known as superimposition. So why does that happen? The second stimulus causes the muscle to contract again before it has fully relaxed the first contraction. So because of the beneficial effect, the muscle is already warmed up and less viscous. The second contraction is stronger. So the first stimulus, the muscle contracts and starts to relax, and during the second stimulus, it comes before the muscle has fully relaxed. So result would be second contraction overlaps with the first one. So the second curve is bigger because the muscle is warmed up from the first contraction, making it easier and stronger. The third is the summation. So when you apply the second stimulus to muscle during its contraction period, the second half of the latent period, the muscle contraction combines into one single curve. The summation curve, so this combined curve is known as a summation curve. So it is taller than the simple muscle curve because the contractions are added together. The base is wider than the simple muscle curve. Other could be multiple stimuli. So when multiple stimuli they are applied to muscle nerve preparation, two main effects we can see. One is the fatigue and other is tetanus. So fatigue, remember, it is a decrease in the muscular activity due to the repeated stimulus. So when the stimuli they are repeated, the muscle eventually it will stop responding, that lead to its fatigue. What could be the cause of fatigue? It is caused by exhaustion of acetylcholine at motor end plate, accumulation of lactic acid, lack of nutrients like the glycogen, or due to lack of oxygen. So in muscle nerve preparation, the first site of fatigue is the neuromuscular junction. So remember, this fatigue is reversible. The muscle recover with rest and nutrition facilitated by washing with the saline. Other is the tetanus. Tetanus is state of sustained muscular contraction resulting from higher frequency stimulation. So when the stimulus they are delivered repeatedly, the muscle they will not have any time to relax between the contraction, that lead to continuous contraction. So tetanus is a sustained contraction that occurs due to the high frequency stimulus. So pathological tetanus, it is also known as lockjaw. That is disease that is caused by Clostridium tetani bacilli that is found in soil, dust. So the bacteria it enter the body through cuts or punctures that lead to muscle spasm and paralysis. So initial muscle spasm is jaw locking. So physiological tetanus is sustained muscle contraction due to high frequency stimulus, while the Clostridium tetani is while the pathological tetanus it is due to the Clostridium tetani bacilli that lead to multiple spasm and paralysis. Now other important thing is rigor mortis. It is the post after death There is stiffness of muscles and joint, that is rigor mortis, and it is due to the result of calcium influx into the muscles. So without the ATP, muscle cannot relax, that lead to prolonged contraction until decomposition.